Hey everybody, it's Nate again, and I'm, as promised, posting sort of a companion video to the video I posted yesterday, both of which are sort of a companion to a little bit of an essay or write-up, I guess, that I posted last week, and it had to do with the science of warp videos. Touched on a lot of things, but one of the main things I was talking about was the wagon wheel effect, which is when a top that is in a video is spinning and appears to come to a stop and switch direction. Now that's due to an interplay between frame rate and RPMs of the top. And yesterday what I did was I put a single white sticker on a plier and gave it a pretty good spin, probably around 2000 RPM, and recorded the entire spin. And what we saw was that only at one point, pretty early in the video, it appeared to come to a stop and go the other direction. For the duration of the spin, it was kind of, lighting up with crazy patterns. It looked like there were 2, 3, and 4 white stickers flashing at different times, but there was only one moment where it looked like it came to a full stop in reverse direction. And I determined that that was at 1800 RPM, which makes sense because 1800 RPM is 30 revolutions per second, and the iPhone that I was recording with was at its default frame rate of 30 frames per second, so it was taking one picture every time the top went in a full circle. So at that very moment, it looks like the top is standing still at 1800 RPMs. So I wanted to kick it up a notch today and talk about tops that are more complex, that have elements that appear to wagon wheel like that much more often because they are repeated elements that appear around the perimeter of a top. For example, the K2 here has 5 holes in the stem. It has 10 holes equally spaced around the perimeter of the collar. It has 15 teeth equally spaced around the top of the collar. And I even counted the knurling, which there are 24 knurls around the top of the stem there. I did not try to count what's going on with that inner disc. It might be a multiple of 24, or it might not be, but let's just forget about the inner disc and concentrate mostly on the holes in the stem, the teeth, and the holes in the collar, and a little bit on the knurl too. Essentially what I theorized was that an element that repeats, for example, 5 times should appear to wagon wheel 5 times as often as the entire top. And remember, the entire top does so at 1800 RPM. And so my theoretical equation that I talked about in that essay was this, right over here, that for any element of a top, you can expect it to have an RPM where it appears to do the wagon wheel effect at every increment of 1800 divided by however many times that thing appears. The technical name for this, as I discovered, was the order of rotational symmetry of that element. And yes, it does sound kind of technical, but all that means is the holes in the stem on the K2 have a order of rotational symmetry of 5, because there's 5 of them. For the collar, it's 10. For the teeth, it's 15. And what we saw yesterday with the plier was that it's single white sticker wagon wheeled at 1800 divided by 1, or once every 1800 RPM. For the K2's 5 stem holes, we should expect that they would do so 1800 divided by 5 equals once every 360 RPM. And remember, when we spin a top, it's starting at a certain RPM and constantly dropping until it falls over and then reaches 0. So that should happen, several times in a typical spin, assuming you're starting at, 2000 or a little above 2000 RPM. For the collar holes, it would be 1800 divided by 10, so we should see those appear to stop and switch direction every 180 RPM as the top decreases in speed. And for the teeth, it is 1800 divided by 15, or every 120 RPM. I didn't write it down, but for the knurling, because there's 24 of them, it would be 1800 divided by 24, every 75 RPM that the top slows down, you should see those knurls appear to stop and switch direction. So I put all of this into a chart, and if you haven't done so already, I put the chart as an image in the comments, but let's take a look at that now. So without going into a crazy amount of detail, the chart just takes those equations I just mentioned and tries to determine at what RPMs, which is the first column here. You can ignore the small number, just let's concentrate just on the big one now, starting with 1800. At what RPMs would you expect each of the elements of the top to do the wagon wheel thing? So for the teeth, which we determined should do it every 120, if you start at the bottom and look up, you can see I've got them doing it at 120, 240, 360, and so on. And the same thing for the collar holes, except they're every 180. The stem holes every 360. The entire top just once at 1800. And then for the knurl, there's 24 knurls, which means it would be 1800 divided by 24, which is 75. I didn't want to clutter this chart up with tons and tons of rows. So what I did was after I had everything else mapped out, I just said, okay, which of these numbers is also divisible by 75? So, you know, at what points can we expect to see the knurl wagon wheel in concert with something else? So, I mean, the answer was basically at 1800 when the whole top does it, at 1200 when we also see the teeth, and at 600 when we also see the teeth. But the truth is you'll see the knurl doing that much more often than what I've got here, because there's 24 of them. There's 24 bumps, and it's going to do it a lot. So anyway, that's the quick explanation. But the cool thing is, when we watched this video, I had this chart in front of me, and I was able to predict, you know, before it happened, when, you know, what was going to wagon wheel next, and it worked. I was pleasantly surprised. So let's take a look at the video of this K2 spinning. The narration was added after the fact, but I mean, I was kind of sitting there while it was going on with this piece of paper in my hand and saying, yes, it's working. So let's take a look. All right, folks, so this is the K2 in action. It wasn't the sunniest day today, but it was good enough. And what you're about to see here is right there is the full top warp. That's when it looks like the entire top comes to a stop. I know the teeth are a little bit blurry at that velocity, as is the knurling, but that is 1800. Now, the next thing we should expect to see, according to the chart, is the teeth. Now look at the teeth. They stopped again and switched direction. That is 1680. I can tell you that next is going to be the collar holes at 1620, and there they go. After that, we'll see the teeth do it again at 1560 RPM. Okay, and there they go. Now the next thing we're going to see is teeth, collar holes, and stem holes all together at 1440. And again, the only way I was to, you know, I'm able to predict that is by looking at this chart that was basically just a hypothesis when I made it, but it really played out. So that's all three of those elements together at 1440. Notice the knurling was still moving. So it wasn't, it almost looked like a full top warp, but the inner disc and the knurling were still moving. So it actually wasn't. Next, we're going to see the teeth again at 1320. And I wish I had a tachometer to verify all these, but like the math works according to this chart, so I'm pretty confident. Next, we're going to see the collar holes at 1260. There they go. Now we're going to see the teeth and the knurl at 1200. So this is the one where I really became sold on it. So we're going to see just the teeth and the knurl in unison. There they go. That happened at 1200. Exactly what I kind of theorized would happen in the chart. Next, we're going to see all three elements at 1080. So the knurl is still moving, but the stem, teeth, and collar, all three together. See how the inner disc and knurl are still moving, but the rest of the top, that's 1080, a number divisible by 15, 10, and 5. And next we should expect to see the teeth go again at 960 RPMs. So there you go. You can see why I suggested printing out this chart to follow along. If you don't have it in front of you, you kind of have to take my word for all this. But next are going to be the collar holes, again at 900 RPM. So we'll see the collar holes stop. There's 900 RPM. And then the teeth, one more time at 840 should be next. There we go, teeth at 840. And then we're gonna see the teeth, collar holes, and the stem holes all together at 720. That should be the next thing we see is teeth, collar holes, and stem holes. And that's gonna happen in just a little bit here at 720 RPM. So everything's kind of slowing down together, those three elements at least. Again, the inner disc and the knurl, not doing the wagon wheel right now, but the rest of the top is. Looks like the entire collar plus the lower part of the stem. So we're coming up on 600 RPM as our top continues to slow down, and this will be the first time since 1200 that we see the knurl and the teeth wagon wheel at the same time, as 600 is divisible by 75 and 15. Let's see, so there's the knurl and the teeth together at 600. Now, we'll see the collar go one more time at 540, and then it gets a little bit interesting because this top is gonna fall over soon. And so once we see the collar, there it goes. That is 540 RPM that it's spinning at right there. So shortly after it hits 480, which is when we'll see the teeth go one more time, the top will fall over. The really cool thing is if you keep your eye on the teeth after it falls over, it really quickly does 3 more wagon wheels. And that's exactly what you'd expect. Even though the top is laying on its side, it's going to spin 3 more times, and it's going to wagon wheel 3 more times, and we're going to see 3 really quick ones. So we'll see that one's 480, then we're going to see another one 360, 240, 120, and then the top stops. Pretty cool. Thanks so much for watching. If you got any questions or comments, feel free to throw them out there. Take care.